In this video, we're going to add one more parent function to our list. We already know y equals x, y equals the absolute value of x, y equals the square root of x. This one is going to do y equals the cube root of x, which I know sounds scary a little bit, but it's actually easier than square roots, I promise. The reason why I say it's easier than square roots is because with square roots, we ran into the problem that you can't take the square root of a negative number and get a real number, a real answer to graph. So we had domain restrictions and complications with that. Cube roots don't have that problem. You can take the cube root of a negative number. The cube root of -8, the number that if you multiply 3 times, you get to -8. Well, since you're multiplying 3 times to get to a negative, you must be starting with a negative. That works out just fine. It's not like multiplying 2 times to get to a negative, which didn't work. Or the cube root of -1 is just -1. The cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. If you wanted to add more rows here, you could. The cube root of 27 is 3. But how often are you really going to be graphing all the way to 27? So usually that's not going to make it onto the table. And we'll graph what we can. 0, 0 fits on here. -1, -1. +1, +1. And then 8, 2, it's even off the chart. So I'm not even going to make it all the way quite there. The key to the graph, though, is that it gets incredibly steep right in the middle, right on that origin, but then it gets very flat very quickly. It's almost like a flattened out S or something like that. And that's a cube root. But because there was no issue with negatives here, our domain is simple. It's all real numbers. Because you can take the cube root of anything. And you can get anything to be the cube root, because you can get negative numbers now. The y-intercept is the origin. And similar to the square root function, this one happens to always be increasing. So the function will be increasing. Its increasing interval is on the entire domain, all real numbers, and it has absolutely no decreasing interval. So what you need to be able to do coming out of this is remember that the domain and range is all real numbers for every cube root function no matter what. And you also have to have memorized what the graph looks like and the table of values. And we're going to do everyone's favorite, which is transformations. So this is going to be the same process. This is going to sound very, very familiar to you because it's the same thing we did with square roots. Same thing we did with absolute values. Our first job is going to be to identify and describe, and this is the part that a lot of you need to remember about, the transformations. Putting the description here is actually part of your job. You're responsible to do this, even if the directions don't say so. In this case, 2 times the cube root of -2 times x plus 3. I want you to notice that this is already factored out. So they've already done some work for us. You might have seen this problem, this exact same function, written as 2 times the cube root of -2x minus 6. And if you would have seen it that way, your job would have been to factor it, that b times x minus h. And recognize that the h is not 6, the h is -3. Okay, so let's identify our b is -2 and h is -3. And so this word, actually writing down these words is important. It's part of your job. If you don't write these words down, don't expect to get full credit. b is -2, h is -3, which means we are going to divide the x values by -2, which is going to flip them backwards, by the way, and then subtract 3. Those are the directions we're going to follow for our x values. For our y values, there's only one transformation that matters for the y value, and that's the a, because notice how there is no k here. So all we're going to do for our y values is multiply the y values by 2. about that. So I'm going to take the parent function, x times n the cube root of x. So remember, I will use our -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. That's our parent table. You kind of just have to memorize that one. It's not that hard. It's just remembering that 8 is 2 cubed, and so we're going to use 8, 2, and -8, 2 for the cube root. Okay, so we're going to make our transformed function, and I'm going to call this f of x because that's the label that they gave us above. And I'll do my x values in blue, so you can remember to follow the directions I wrote in blue. I'm going to take all of these, and I'm going to follow these directions to get to my new column. So I'm going to take the -8, -1, 0, 1, 8. I'm going to divide the x values by -2, and then subtract 3. So first, -8 divided by -2 is 4. Subtract 3 is 1. I was taking this -8, following my directions to turn it into a 1. -1 divided by -2 is 1/2. Subtract 3 is -2.5. 0 divided by -2 is 0. Subtract 3 is -3. 1 divided by -1/2, divided by -2 is -1/2. Minus 3 is -3.5. And 8 divided by -2 is -4. Minus 3 is -7. So those are the x values. The y values are a little bit easier because all I'm doing is doubling. -2 times 2, -1 times 2, 0 times 2, 1 times 2, and 2 times 2. So I'll put some axes on here. And we'll graph our coordinates. 1, -4, -2.5, -2, -3, 0, -3.5, 2, -7, 4. And hopefully you can see the pattern there. Hopefully you can see the cube root shape. The very steep in the middle, much flatter on the outsides. And there's the cube root. Remember to just identify your domain and range of every function you always make. For cube roots, though, that is super fast because the arrows go in both directions, side to side and up and down, so the domain and range is going to be all real numbers no matter where that graph ends up.